I see. So that means we might need to also go back, because on my side I prepared a topic for work done on an object. So that means we might need to then change and go back to the grade 11. I'm not sure. What do you think about that one?
Yes, sir. That's okay, sir.
Okay, let's see. But would you agree with me if I say this is the topic that is more difficult when compared to others?
Yes, sir.
Yeah, because let's see, physics. Yeah, according to me, those other topics they may be a bit challenging, but when you compare the topics, I think this one is more challenging that other one. So I've got one which I think it's even more challenging. Let me quickly share my screen and then let's see, what am I going to do? Okay, the stream is that. Okay, the screen and start podcast. Okay, and can you see my screen?
Yes, sir.
Didintle, can you see my screen?
Yes, sir.
Okay, then it's fine. So let's see. Here we've got two blocks of mass 8 kg and 4 kg respectively, which are joined with an inelastic string of negligible mass. The string runs over a frictionless pulley. The 8 kg block is on a horizontal surface, while the 4 kg block is on an inclined plane of 40 degrees with the horizontal. The coefficient of a friction for both blocks is 0.2. The 4 kg block accelerates down the slope. I'm not sure at this stage, are you able to state Newton's second law, or you only practice it a day before you go to write?
No, I can, sir.
Okay, then it's fine. We can just skip it. And then on 4.2, maybe let's discuss 4.2. How would you draw a labeled free body diagram on all the forces acting on the 4 kg?
Okay, so, sir, I would draw the force, the tension force on the left-hand side, and I draw the the normal
Tension
force
or in that
above
direction.
yes, sir.
Okay.
And then across going up would be the normal force, sir.
A normal force going up like that.
Yes, sir. And then there would be a FG parallels, sir.
FG.
I mean FG perpendicular, I mean, sir.
FG perpendicular. Okay, in terms of the direction, which direction will it go? Is it up or up towards the right, up towards the left, maybe down or down towards the left, down towards the right?
Just down, sir.
Okay, down like that.
Yes. And then there will be a FG parallel going to the right, sir.
Wait, so you say this one is FG what?
Perpendicular, sir.
Perpendicular, okay, and then we have this one being FG parallel, you say.
Yes, sir.
Okay, then it's fine. I think I now know where to start. Just maybe to make you aware, Didintle, I've got flu, so my voice is on and off, honorable member. Don't be surprised. But one thing for sure, I think you will be able to hear me when I speak. So this is the situation Didintle. So we will have an object which will be on a horizontal flat surface like that. So when we have to draw the forces acting on that object, number one, we need to be aware of all the possible forces which may be acting on that object. Let's have a list of those. So you always list them in this order. You must first think about FG because this one, it will always be there. It is always downwards, this one. Nay.
Yes, sir.
And then you will have a normal force which will always be perpendicular to the surface. I'm not sure if you can hear me on that one, Didintle.
Oh, yes, I do, sir.
Yeah, so that means if the surface is at an angle, it just has to be perpendicular. And then the other force that you should think of is this one of force apply. This one will depend on the examiner in terms of how it is acting on the object. And you just need to know that it's either it is a push or a pulling force. Makes sense?
Yes, sir.
And then we are also going to be having this one of a frictional force. This one, we will be told by the examiner to say the surface is rough, or maybe there is a kinetic coefficient or the coefficient of kinetic friction, which is whatever. Then it's another way of us knowing that a frictional force exists. So lastly, we will have the tension. Tension will always be there if we have two objects connected by a string or a rope. Make sense on that one, didn't?
Yes, sir.
Okay, so now let's try to draw forces acting on an object. So you see, on this object, this force will always be there from the center going vertically down. This one being Fg. If you don't want to say Fg, you can say the weight. What we know is that the formula is M times G. Do you agree there?
Yes, sir.
Yeah, so we are forced to have a normal force. Can you maybe give me a reason why we are forced to have a normal force, Didintle?
Because if we didn't have a normal force, the object would be sinking through the ground, so it would continue going down, sir. The normal
Yeah,
force is set above the ground, sir.
so but what proof do we have, or what's stopping that object from continuing to go down?
The force exerted from the earth to the object, sir. So
So we say the surface. It is the surface
the surface, sir.
that, yeah, so the normal force will always act perpendicular to the surface, forming that 90-degree there. Can you see? Also, forming that one, it's also forming 90 degrees, meaning it's vertically down if the surface is flat like that. So that means in this case, we don't have a tension because it's just one object. We don't have frictional force because this object is not moving. And again, there's no applied force. So that object is just sitting there where the weight is balanced with the normal force. Makes sense there, Ding?
Yes, sir.
Okay, so now, in case if we have an object, an applied force in that direction, you just need to know, is this force applied a pulling or a pushing force?
It's pulling, sir.
Because of the arrow, it's pushing. Only if it was acting away, it was pulling.
Yes.
Yes, but it is pushing at a certain angle. Can you see? So
Yes,
when we
sir.
say push or pull, we mean is it pushing the object or pulling the object? That's how you can understand the push and pull. So now, with regards to this force being applied, you can see that it is applied at an angle. This one is that of a pull. Sometimes it could be applied in that manner, which is a pulling force. But you can notice that these two are actually acting at a certain angle. So that means because let's maybe focus on that one force applied number one, that one which is pushing. It is pushing that object at that angle of theta, but the object is not moving in that direction of the arrow. Do you agree? It will be moving towards the right, even though the force is acting at an angle.
Yes,
So
sir.
that is because the force which is actually pushing it towards the right, it is the component of that force applied, which is force applied number one cos of an angle. And then we also have this one, which is going down, which is the force applied number one, a sine of an angle. So if a force is applied at an angle, just be aware that it also has the components. I'm not sure if that makes sense, Didintle.
It does, sir.
Yeah, so in this situation, it means we will have that force going up. That one of the component of force applied, it will be sine of angle alpha. And then we will also have this one in that direction, which is therefore going to be that force applied, but this one is cos of an angle alpha. But this one, the horizontal force, it doesn't have the components because it's just a horizontal force. Can you see there, Didintle?
Yes, sir.
Okay, so now let's try to have a look at forces which may be acting on an object which is on an incline. So we will therefore have a look at how those forces look like, and also how do they relate to an object which is on an incline, either moving up an incline or down an incline. And do that. I'm trying to remove that. Okay. So maybe let's say we've got that being the surface, and then there's the incline, and then we have an object there, and then on that object there is force in that direction, and then again they say this surface is rough. So let's try to identify all the possible forces which may be acting on that object. So you always start with this one because it is always there. It always exists. This one of FG. Can you see the thing?
Yes, sir.
We have a normal force. So the normal force must always be perpendicular to the surface. So it is forced to be in that because it must form 90 degrees with that. It can't be straight up because once it's straight up, it doesn't form 90-degree angle with the horizontal. Does it make sense?
Yes, sir.
And then now, the one for the friction will always oppose the movement of the object. So the object is moving in the direction of the applied force, which is in that direction. So that is why the frictional force is opposing. The tension is not there because we don't have two objects connected by a string. I'm not sure if it makes sense what I've explained, Didi.
Yes, sir.
Okay, then it's fine. So what I'm now going to do, it is to draw a labeled free body diagram on the 8 kg, and then you will try again the one for the 4 kg. So that one on the 8 kg, it's obviously on a horizontal surface, so I'll just do that. And then I'm just going to start with this one, which is always there, and say, this is our FG, and then this one should be there vertically up, which is our normal force. then we will definitely have this one in that direction, which is going to be the tension. And then because they said there is the coefficient of kinetic friction, then it means we do have our frictional force. No applied force on the 8 kg. That's why I'll just remain with those 4 forces acting on that object. I'm not sure if that makes sense, Didintle.
It does, sir.
Okay, so now, maybe on your side, I'm quickly going to fetch my electronic pen and then I'll be back. But on your side, try to draw a labeled free body diagram on the 4 kg. No?
Okay, sir.
Okay, are you still working on it, Didintle?
Sir, we would start off with the FG going down, sir.
Okay, let me quickly do this. Let's see. Like my electronic pen is not fully charged. I don't know why, but it's fine. Let me do this. I'll use my finger. Then we have, you say, a FG going down. Okay.
So then you would have a slanted line towards the right, and that would be FN, sir.
Okay, we're going to have FN or just N. Okay.
And then we would have one line that is perpendicular to the FN going to the left upwards, and that would be,
Like that.
yes, sir.
Okay.
And
And
that
this
would
is
be the FA, sir.
FA. Okay.
That's it, sir.
Okay. So, where is where are those masses, in which direction are those masses moving, if they are moving?
To the left, sir. No, to the right, sir.
To the right. Okay, maybe this is what I'm going to do, Didintle, on your own. Sorry, try to read that statement, and then we'll come back to this question of a free labeled body diagram, just to try and find out if we do have the normal force, if we do have FG, if we do have force applied, and if we may be having other forces. And also, this question, normally if it's allocated 4 marks, it means you've got 4 possible forces acting on that particular object. Did you hear me on that one?
Yes, sir.
Yes, for now, read through that statement, and then let me know if you want your labeled free body diagram to remain as it is, or if you want to change. And then I will guide you afterwards.
So, sir, because you mentioned that it's for 4 marks, would I then be wrong if I if I erased the FG and I did the FG parallel and FG perpendicular, sir, just in the same direction, sir?
No, because you see, those two forces, they represent one force. It's not like it's two separate forces.
Oh, sir, okay, sir.
Yes. So when you draw a labeled free body diagram, avoid drawing the F parallel and the F perpendicular. Just use the one which is always going down.
Okay, sir.
Yeah, so read through the statement and then let me know if you want to change.
Okay, sir. So, sir, then I would then add like kinetic friction on the, so going down.
Down like this.
No, sir. The opposite of FA, sir.
Opposite of FA, meaning in that direction.
Yes, sir.
Okay, okay. What did you say again about the movement?
I said kinetic friction, so it's moving up the slope, sir.
Up this slope. Okay, then it's fine. Let me remove all of that. And then we will reread that statement and highlight when, okay, two blocks of mass 8 kg and 4 kg are joined with an inelastic string of negligible mass. So because they are connected by a string, that means a kinetic, a tension will exist simply because of two objects being connected. And then they say the string runs over a frictionless pulley. Okay, the 8 kg is on a horizontal surface that we can see, while the 4 kg block is on an incline plane of 40 degrees with horizontal, yes, that we can see. The coefficient of kinetic friction on both is that. Okay, so that means we have that, which tells us more about the existence of a frictional force, and this is on both blocks. So that means both blocks experience frictional force. Now they say the 4 kg block accelerates down the slope. So can you see, Didintle, that there's no way the 4 kg can accelerate down the slope and then everything else is moving up or towards the left? Can you see?
Yes, yes, sir.
Yeah, so that's why I wanted you to read that statement. So now, if we have to do a labeled free body diagram on the 4 kg, we will say number one is this one, which will always be there, FG. Number two, it will definitely be that one being the normal force. Number three, it will be this one, which is going to be the tension, because now how we are drawing this, it's like we cut it somewhere there, or we just cut it in the middle. Then we are just focusing on this one. For additional information, we will come back and draw that. No, but for that one, we have drawn it already, isn't it? The 8 kg. I've drawn for the 8 kg. So the other thing that we are having, Didintle, it's a frictional force in the same direction as the tension. is the frictional force in that direction. We do not have an applied force, Didintle. They did not give it to us. We were not told. They did not mention it. Can you see Didintle?
Yes, sir.
So this unit is moving down the slope because of a FG parallel. So what makes it to move is because of FG parallel, not an applied force. It's like you putting a calculator on a textbook. If you slope it a bit, you'll notice that your calculator is going to start to slide down that slope. Not that you pushed it, but it's because of FG parallel. Makes sense?
Yes, sir.
So now, in terms of doing calculations, that's when you need the FG parallel. The FG parallel so that it opposes those forces. That's what you need for the purpose of calculations. And then this one, FG perpendicular, it is the one that opposes that normal force. Then those two forces, they replace this single force. So you only do that when you start doing the calculations, not when you do a labeled free body diagram. Does it make sense, Edith?
Yes, sir.
Okay, then it's fine. Something that I want to make you aware of. Do you know what is the formula for frictional force?
Yes, sir. It's the coefficient times the n, sir.
Yes, times the normal force. And do you know the for the normal force?
Yes, sir. It's the mass times the gravitational force, sir. So 9.8, sir.
Okay, so maybe let me explain it to you this way, Didintle, and say, if we have an object like that, and we have a force in that direction acting at an angle. You remember I said this, we are going to have the component of that force applied, which is going to be force applied sine of an angle. And we will also have its component in that horizontal direction. Do you agree there, Didintle?
Yes, sir.
So we will also have a normal force acting vertically up. We will also have FG acting vertically down. So what happens is that because this object is not moving up, it's not moving down, it means the up forces balance with the down forces. So that means the normal force, including that FA sine of an angle, they balance with FG. I'm not sure if you understand what I'm saying there, editing.
I do, sir.
Yeah, so can you see that now it means the normal force in this case will be equals to Fg minus force applied sine of an angle.
Oh, yes, sir. Yes, sir.
So that means the formula for the normal force is not fixed to 8 being equals to mg. Depends on the situation. It's all about the upward forces balancing with the downward forces.
Okay, sir.
Yeah, so now let's look at this situation where we are having that applied force, of course, at an angle, but this time around, it is a pushing force. So let's have a look at how the forces are going to balance. So you just need to know that if the object is not moving up or down, but moving left or right, the up and down forces, they balance. they balance. So maybe let's say that. So now, what did I want to say? I think I wanted to say, let's say we have a force applied like that. So when we do calculations, we look at its components, and its components, we're going to have one going down, which is going to be force applied sine angle. Always the one for vertical is a sine, and then that one a force applied cos of an angle. And then in terms of other forces, we do have that force in that direction being the normal force. Then we also have that one being our FG. Do you agree there?
Yes, sir.
So now that means when we talk about the up forces balancing with the down forces, an upward force that we have is the normal force, which will therefore in this case be equals to Fg that is going down, include Fa sine of an angle going down. Can you see in this case it's no longer Fg minus that, but it's Fg plus that. It's because we are having a pushing force. And when we're having a pushing force at an angle, it has a component which is contributing in the downward direction. Make sense?
Yes, sir.
Okay, then it's fine. But did you see a labeled free body diagram on this specific question in terms of how we do it?
Excuse me, sir?
Do you understand the labeled free body diagram for this specific question?
Yes, sir. For the
Okay, so now
for the 4
for
kg, sir.
4.2, yes.
Yes, sir.
Okay, for now, let's try and calculate the frictional force between the surface and the 4 kg block. Yes. Okay, you can on your side try to work it out, check if it makes sense, and then let me know what the answer is or how you've worked it out. 4.3.
Yes, sir. sir.
Mm-hmm.
I calculated it and my answer doesn't look right. I just wanted to ask if my approach was like, if my approach made sense. So I said, if x equals the coefficient times the normal force, and
So you
then
said what did you say? FF
fx.
or FX?
Yes, sir.
Okay,
And
let
then I
me
said
quickly rewrite it as FX. Okay, FX is equals to
the coefficient times n, sir.
mu times N. Okay.
And the coefficient is given to us at 0.2, and then I said times
Mm-hmm.
mg sin theta, sine
G
theta,
sine
sine.
theta.
And
Okay.
then I substituted the value I got from mg, which was 39.2 sine 40.
39.2 sine
Sorry, sir, 25.19.
25.91.
19.
Okay, 19.
And then my fx was 5.03, sir.
Your FX was 5,
3, sir.
okay,
Newtons.
5.3 newtons.
Yes.
Okay. Let's try to make sense of it. This part, mg sine angle, which one is that one again?
That's the normal force, sir.
So I'm just trying to understand if that is FG parallel or FG perpendicular. Which one?
Oh, so that's if, hold on. That's parallel, sir.
That's parallel, okay. And then the FG parallel, is it the one that is balancing with the normal force?
No, sir. No, sir.
So
So it's cos, sir.
it has to be cos, because the one for cos is the one that is equals to n, that is balancing with the n.
Okay, so I first did cos and I got 6 newtons, and then I canceled it out, and then I did with sine.
But you know, in court, they won't go with that one, isn't it? Because you cancelled it.
Yes, sir.
So you're still going to jail.
Yes, sir.
So it just has to make sense, honorable member. It has to make sense. So the reason why you use the one for cos, it's because it is the one that balances with the normal force. So you see there where we have our normal force, and then we said we had our FG in that direction. And then we therefore say this is the one which is our FG perpendicular, and this is the one for what is it? FG cos of an angle. And then this is the one which is parallel to the surface, and then this is the one for FG sine of an angle.
Yes,
So
sir. May I
when we
please
balance the forces, yes.
then correct my calculations just to show you that what I did when I used the cos, sir?
Yes, I'm 100% sure in terms of the value, it will be correct. I'm just concerned about it having to make sense. It's like it's like I want to remove that confusion of you guessing, because the moment you do this one and then you cancel, then you do that other one, it means there's a reason for not being decisive. It's like you had two options and you did not choose one by making sense of it. Because yeah, you just have to choose one, and there must be a strong reason why you go with that option. So this is what I'm trying to point out to say. You just need to be aware that the upward force in that angle is the one that balances with the downward force in that angle. And that downward force is the component of that which is perpendicular to the surface. Does it make sense now, Didintle?
Yes, sir.
Yeah, so the one for FG parallel, yeah, that one, it's more like an applied force, that one. So it wouldn't interact with what is it, the normal force. So you can just regard that one as the applied force. If the applied force is not given, even though it shouldn't be regarded as an applied force. The reason why I'm saying applied force is because it is the one that is making that object move. But sometimes it can act as a opposing force. Imagine if that 4 kg was moving up the slope. That means it would be moving up the slope because there's an applied force. Then the FG parallel would act as an opposing force, and you can still have another opposing force, which could be friction. Does it make sense, Didintle?
Yes, sir.
Okay, so now moving on 4.4. So it's more like I'm saying you will get it correct when you change sign but put a cos there. It should be 6.01 Newton, and then you don't leave it there. You must say either up or down the slope. Which one will it be?
Down the slope, sir.
Why down the slope?
Wait, what do we call frictional force? It'll be up the slope because it's opposing the motion, sir.
Yes, it's opposing the direction of the movement. Okay, so 4.4, they say calculate the magnitude of the acceleration of the system. Calculate the magnitude of the acceleration of the system. Okay, do you have an idea of how you can work it out?
I think so. Yes, sir.
Maybe without you having to calculate it, can you let me know in terms of what you're going to do there?
Okay, so we're going to first start by saying F naught equals MA, and
Mhm.
then we're going to use the the frictional force that we just calculated. So the frictional force that we just calculated is 6,01 newtons, and we're going to use the 4 for the mass, and then in the calculation, the frictional force, and then yeah. So let me write it down.
Okay, so just remember what the question wants. It's fine, you can write it down. Just always remember what the question wants. Then, yes, you can now try to give it a try.
Okay, so so
Mhm.
I just noticed that we don't have a value for tension, and we could then simultaneously calculate for acceleration and tension because
Did you say we could or we couldn't?
We could, sir.
Yes, no. You do anything possible, but the hint that I can give you is that you cut it there, then you formulate for that 8 kg by making T the subject of the formula, because we know that the tension on the 8 and the tension on the 4 is the same. It just acts in opposite directions. And maybe let me explain that part. It might worth it. So if you have two objects connected by a string, what happens is when you do the calculations, you will need to cut it somewhere in the middle. So that means on this object A, that being B, on object A, the tension is in that direction. But on object B, the tension is in that direction. I'm not sure if it makes sense, Didintle.
Yes, sir.
So that means before you do calculations, you just need to complete a labeled free body diagram on this object, then you formulate and you make T the subject of the formula. And then you still do the same on this one by saying F net equals MA, also here F net equals MA. On both, you make T the subject of the formula. Then you're going to equate the two equations because that tension and that tension is the same or equal. After equating them, then you just solve for your acceleration. I'm not sure if that part makes sense, Didintle.
Yes, sir.
Yes. Okay, maybe it's fine. Very quickly, let's do it together, and then I will leave it to you to finish it off. But for now, let's see. So this is how you would work it out. When we look at that 4 kg, it looks like, no, the 8 kg, it looks like we just have the tension and we also have the frictional force. Any other forces is the up and down, which are balancing. Do you agree there, Didintle?
Yes, sir.
So that means we have tension, which is positive because it's towards the right, minus frictional force, and this is equals to MA. So that means tension is equals to MA that we plus it with the frictional force. Do you agree there?
Yes, sir.
Okay, and then on the 4 kg, we have that component of FG sine of an angle, and then we have this one in that direction, or that one opposing, which is what? Which is the frictional force. Do you agree? Because both objects are experiencing the frictional force. We also have the tension. I'm not sure if you agree with me on that one, Didintle.
Yes, sir. I do, sir.
Yeah, so that means towards the right as a positive, we have FG, sine of an angle. This one of the tension is minusing. Also, this one of the frictional force is minusing. And this is equals to A. Obviously, we're just using this formula of F net being equals to MA on both the situations. Can you see, Didintle?
Yes, sir.
Yeah, so that means we just make tension the subject of the formula. So the tension will end up being FG sine of an angle and then minusing MA minusing frictional force. I'm not sure if you agree with me on this one.
Yes, sir.
Yeah, so can you see? Now that your tension is the same, then you can equate those two formulas. And that's how you're going to be solving for the acceleration. Because you on this object, you do have the mass, isn't it?
Yes,
This
sir.
is what you're looking for. That one you calculated it in the previous question, isn't it?
Yes, sir.
Yes, this one is mg. You do have the info, the angle you do have, the mass you do have. This you calculated on the previous calculation. This is what you're looking for. Do you agree?
Yes, sir.
So all that you need to do is to equate both, substitute, and then solve for A. So I will just say the A that you must get is this one. The A, you will just have to work it out on your side, but you must work towards getting this. 0.29. Makes sense there, Didintle?
Yes, sir.
Okay, so now 4.5, they're asking how will the acceleration compare if the positions of the 8 kg block and the 4 kg block are switched?
It'd be greater than,
greater than, okay, reason?
because the 8 kg, the mass is way bigger than the 4 kg, meaning it would move faster down the slope, sir.
Yes, exactly that. So again, you can still say the FG parallel will increase. What makes it to increase is because when you substitute the mass on the formula, you're substituting with the bigger mass. But my question is, what's going to happen to the tension? Will it increase, decrease, or stay the same?
So it's going to decrease.
It's going to decrease. A reason?
Because it's easier again for the 8 kg to pull the 4 kg object. So then that would mean the FG parallel, because it's lower than the tension, which is the tension will also be lower. So
Okay, so every time when you think about the tension, you must think of it this way and say, if you have an old person there, another one there, they are pulling each other, and then we just have one honorable member there. Can you see? Think of the tension as the pain. So that means the pain experienced by the rope itself. The pain experienced by the rope, do you think it will change if we now swap and put that one person there and then put those two on the other side? Do you think the pain experienced by the tension will increase, decrease, or remain the same?
so will it then remain the same?
Yes, it will remain the same because it is still being pulled by the same amounts or by the same number of people. So it will experience the same pain. Whether you swap or not, it makes no difference. Unless if you make changes to the mass, then that means it might experience more pain. So the tension is not necessarily about that pulling, or it's not necessarily about bigger mass pulling a smaller mass or the smaller mass pulling bigger mass. At the end of the day, the pain felt by the string will remain the same unless if you change the mass. Makes sense?
Yes, sir.
Yes, so such a question may come in multiple choice type of questions. You just need to remember the tension is the pain experienced by the rope. So that's why we say on the 4 kg, the 4 kg is like it is pulling what is it? the 8 kg, and the 8 kg is like it's pulling the 4 kg. So yeah, you just need to be aware there in terms of the tension being the pain experienced by that. And then when you do the calculations, you cut it. And then in terms of your arrows, they are away from the object. Same value in terms of the tension, but opposite directions. So that will be it, Didintle. I'm hoping that you did learn a thing or two there. So what you can do for now is just to look for other questions that has a memo and then check how they've done it or how you would done it, and try to make sense of the memo if it makes sense. And then you will also check this lesson to look into what I've explained, and then everything else should make sense. Any questions from your side, Didintle?
No, sir. Thank you, sir.
No question. Okay, no, then it's fine. On my side, Didintle, until we meet again, I'll just be focusing on my food. Until we meet again.
Yes, sir. Get well soon, sir.
Thank you, Didintle. Bye.